Hi, I'm Anthony Ottawas, and welcome to my talk on the security of an API developed by AI. This is me, Anthony Ottawas. A little bit about myself. I'm the head of APIsec Labs. Worked in tech and security as a professional for over 20 years, and I published a book on visualizing streaming data, which often does intersect with security. I have been using AI tools personally and professionally for most of my career. We used to uh, discern more between machine learning and neural networks and deep learning and all that kind of stuff. And it seems like a lot of those things are all lumped into AI now, and that's fine. But I have been messing with them and seeing their evolution over time. So for today's talk, the tools and technologies I used, I've got GPT, which I think most people are familiar with if you're in the tech space. GitHub Copilot, which helps me autocomplete some code inside of the VS Code window. The tool from my company, APIsec, which will do the security scanning. And then any graphics that you see are likely created by a image generation tool called Leonardo.ai, similar to Midjourney if you are familiar with that. And then the technology being used for the API itself is going to be Express.js web server on Node.js using Firestore serverless data store for the back end. So in order to develop an API, I had to come up with a scenario to kind of role play. What am I going to be developing? And I wanted to make sure that it was something that was kind of a realistic thing, a realistic need, and was worth protecting. So what I came up with was an expense management application. And I have this fun scenario where Joe's accounting wants to get with the times. You know, the guy's been using QuickBooks or spreadsheets since forever. And he wants to get an API online in order to attract some new business and get some new clients who also say that they would love to work with him, but they need to automate their processes. And it is pretty common or a very likely scenario today that if somebody's getting started with something new like this, that they are actually going to start with an AI generated set of code in the beginning and or even to fill in functions later on, and we'll talk about how to do that. So how you do that in AI is called prompt engineering, and this has become a popular topic, I think, in no small part due to how crazy the clickbait has been on YouTube. On, you know, you can make insane amounts of money a year if you learn how to uh, whisper to AI, and a lot of this kind of stuff is just it's like, sure, maybe if you have the skills behind it, which I'm going to further explain what that means. Uh, you don't just talk to AI, you have to know what to ask it, right? And the knowing what to ask it is, you know, you usually start with very high level things that you're asking it. It will give you steps, then you fill in the details, and you start assembling all the responses that it gives you. We're going to walk through some of these, and if you ever change your thread of conversation, then you need to bring a lot of the context with you into the new thread so that it has some consistency between the two things. But all of those tricks are called prompt engineering. And you can see a prompt below that I used in this thing. I like to start things with the data schema. The way that I've developed through the past was using the data schema as a contract and how things are going to interact. So the first thing that I asked it was, you know, how am I going to do a data schema for travel expense management? It was able to give it to me in very detailed JSON data schema format. which we will definitely show in detail later as well. So what were the results for a developer? Surprisingly, I got tons and tons of code that didn't have any errors. Uh, and that in itself was impressive. And there was a lot of copy and paste from either the previous steps to a prompt or from a generated response to my code window. But when I did that, things kept working. So that was pretty cool. When you ask it to fill in a bunch of functions, it does repeat a lot of things. So if you wanted to refactor that, I guess you could ask the AI to help you refactor it and create more generic functions that you could then reference for things like your status codes or your error messages or things that it repeats frequently. But it doesn't do that on its own. Similar to how it's not going to do security on its own. And we're going to show that in the next slides. I do think that it was an excellent reference for common patterns and practices. There were several things that it came up with that I didn't immediately think of that were going to be required. And if I sat there and thought about it or started developing the application, I would be adding things into the schema as I went. But this actually gave me a lot of things that I would normally have added later on in the project, and it was helpful to have them early on. So as an example, I show on this slide a number of things that I generated. It did the JSON schema. It scaffolded the entire API out for me, function by function. I was then able to take those functions, ask it to fill them in. It filled them in. It created example data for me. So when we had a JSON schema that had users, it would create users data that I could then load in, which was very helpful. And then even a OAS spec for the API for Swagger or anything else that needs to read it. So the results for security weren't quite as rosy. There's some things that it could do well, and just like for development, it's good for tedious tasks and references. But one of the interesting things about AI is it will never shoot down an idea. This is very cool when it comes to exploring different ideas, but it's not so great when it comes to security, where maybe you should be shot down on an idea. Storing sensitive data in plain text on disk should be shot down. There's certain things that if you ask it to do it, it shouldn't just tell you, okay, here's how you do it. And similar to doing the development of the individual functions, when it comes to the security stuff, you have to integrate the responses yourself. You have to know what to ask, and then you have to integrate it. And in order to know what to ask, you would have to have some experience in that area in order to know what to ask and then ask it. And then so give you just a good example of the security of what was written. I have some examples here. When I asked it for the direct deposit function, and obviously this is financial information, this is as critical as it gets when it comes to what you need to protect with your API. It just says, okay, we're going to take our input data right from the request body and we're going to write it to a record. Right? There was absolutely no data scrubbing for the correct type. There's no obfuscation, there's no masking, there's no strategies here whatsoever to protect this data. And there was no information that came along with it that said that maybe you should protect it. So it just an extreme example, but a realistic one that it gave me. So then when I asked as a follow-up, I said, literally, how can I secure my Express.js API application? It gave me a very good list of things that you need to do. And, this list is, displayed on the slide. But the striking thing here is that only one of 7 of these things were ever included in the code that it gave me. It gave me the JWT for authentication instead of using something more generic, like just a plain text username password, which is great. But anything else was not there. So while you can ask for something specific and get it like this, you would have to regenerate all of your code in order to get any of this included, and then it might be a little difficult. When I look at the security more in detail, just as a experienced professional and doing code review, there's a number of things that pop out to me. Obviously, like we already mentioned, storing sensitive data in plain text is a huge red flag. But also the fact that none of the data types were specific, right? Account numbers have a specific format, direct deposit numbers, ACH, anything of those natures, you want to define very specifically exactly what is correct. You don't want to just try to filter out all the possible ways that it could go wrong. You want to say exactly the format that it needs to be, and none of that was there. To the extent that account numbers were strings when they could have been integers of a specified length. So that is a core security thing that definitely needs to be improved. The auto incrementing IDs, I think this is just such a common design pattern that it would be hard to not get this at some point. And we'll talk specifically about this vulnerability later. Helpful error messages. So I actually found it very nice that it gave me all of the good error conditions that could happen throughout the process, because error conditions are tedious to individually code and find the right HTTP status code. And it provided all that for me. But it also was a little too helpful in that from a malicious perspective, the error messages were giving away a little too much information. And I've got that detailed as well. And like I already mentioned, there's no input validation. I have this famous image on the slide here for a reason. It comes from a World War II data analysis example I'm not going to go into detail on, but it brings to mind the thought that everything has been trained on code without any quality associated to it. There's nothing that has trained it on this is insecure code, this is secure code, and there's no difference between those two sets. It's all like the open source code that was trained on. I think in the future this will change a bit and code will be a little more specialized and better trained. But for now, I don't think that it understands the difference in quality of code when helping generate and answer your questions. So once you generate an API with AI, or even if you did it by hand without any assistance, there's a number of ways that you're going to want to find security issues in your API. Obviously, you can have an expert review it, and this is always a good option. It's just limited by how much time that they have and what experience they have finding those vulnerabilities. This can especially become an issue when you have a very frequent um, deployment process and code update process that will require a lot of reviews and might completely take up the time of that expert. There's static analysis tools that will look at the code, and those static analysis tools would definitely find the lack of input scrubbing. I've seen these tools be able to tell you that it took a user input and it directly put it to the command line or something like that, and that would definitely be helpful. And then there's dynamic analysis, which is being able to actually test your code and find things like logic errors or permissions errors or things that might not be obvious when you just look at the code. And this is a great way of being able to scale past the limitations of an expert reviewing it. Now, I did try to get AI, the chat GPT, to find vulnerabilities, and I think there's some clever prompt engineering in order to get it to start answering you. But for the most part, it won't tell you what the vulnerabilities are, because it's just going to tell you that it doesn't want to be used maliciously. So, that makes sense. Nobody wants the tools to be super hackers for malicious purposes, and anything that's just released to the general public is going to be difficult to, uh, have any accountability on that. So I did run our tool against it, and there's a number of things that immediately pop out. We've got configurations issues. That's the kind of stuff that Helmet would have helped with, or configuring cores. The incremental IDs, also known as the insecure direct object reference vulnerability. Timing injection attacks. This is the kind of stuff where you try to do an injection that has a wait time, and you detect that wait time in the response. User enumeration, this is the type of stuff where the errors are going to let you know if a user exists or doesn't exist, so you can brute force the user list. Rate limiting, RBAC and ABAC, which are permissions things, and then anything that is found in your spec that pops out. If I look in detail at something that's just a little easier to understand what's going on here, we've got this problem with the indirect or the insecure direct object reference that started all the way with the JSON schema that I asked it to produce. The JSON schema started with user IDs being just numbers, and those numbers auto increment. So we picked that up in the API scan, and then when I feed that back into ChatGPT and say, hey, the scanning service found these incremental IDs, how do I fix it? It came right back and said, oh, yeah, this is the name of the vulnerability. This is the strategy to, uh, in order to fix it. And here's the libraries to use. Very helpful. The only problem was it didn't do that to start with. It didn't, it doesn't volunteer this stuff. You have to go through the process of finding the issues and then asking it how to fix them. And that can be, kind of a pain, especially when trying to make that code compatible to everything else once it's all been written. And to show you another issue in detail when it comes to the errors that it provides, which, like I said, was very useful, it's also useful for malicious purposes because it will immediately just tell you if a user's not found. And this is like in forgot password functions. So this is not something that's going to be rate limited, or you're not going to get locked out of the system or anything like that. And you can brute force this all day long and find out what users actually exist. And then you have half the puzzle, and you can start piecing it together from there. So I did similar things with the other vulnerabilities found just to see what kind of responses it gave me, if it consistently gave me good responses in order to secure my API. And it did. But you can see for each one of these, whether it was for how to prevent injections or the user enumeration or even how to protect your PII data, each one had, several steps to correct it. And again, none of those were included in the original generated code. And each time we add one of these steps to all of the functions or add these all as prerequisites, it starts building in the complexity of what you're going to have to edit and make compatible to each other, and just keep the whole thing running. Something else to consider, and I think is easily forgotten, especially for maybe younger generations who are not used to or haven't seen the progression of free services over time, is asking what their business model is. If something's coming to you for free, you want to know, how are they making money long term? What is their business model? Uh, Very rarely is somebody in it for altruistic reasons. So you need to understand what that means to you. Usually what it means is anything they generate is going to be theirs, right? So if you need something proprietary, maybe having it generated on AI is not the best use, especially from a free one. And anything that you give it as a prompt, they have the rights to use. and that can be a problem for people as well. They probably want certain critical information to remain private and just never put it into a free service like this. There are local installs for most of these AI tools, and I think they're pretty cool and useful. I've installed several myself, but they definitely take some time and skills and experience in order to maintain and keep running. So my overall conclusions on how this whole experiment went, I really like the idea that there's no bad ideas, and if you need more ideas, all you have to do is ask. So that's actually very valuable compared to asking a general community of people who may not be invested in the topic or have time. Um, but because it never will shoot down an idea, I call it infinite set of yes men who will go and find stuff for you but never tell you something's a bad idea. Its security is about as good as it did text in images. If you noticed on the logo that I had for the accounting firm, I actually told it to say Joe's Accounting and it didn't say anything legible. An experienced person is critical to the successful use of these tools. I think that's going to remain true for quite some time. And also, what's going to continue to be the case is that they are rapidly evolving. The direction that I see them evolving is, closing some gaps like fixing, things like text in images. Even this image in the middle of the slide is AI generated. And if you zoom in, nothing makes any sense. It's just kind of gibberish. And I think a lot of that kind of stuff will make sense over time. But offensive and defensive security models will start to diverge as specialty models that are trained and become commercial products that compete with each other. At least the defensive products will compete with other defensive products to see which ones protect best and vice versa. And then the code development should start to diverge when it comes to training specifically for a language in a specific industry and whatever features and needs that you have. And that's going to start distinguishing products beyond being just general purpose. So that's it for the talk I have today. Thank you for joining. I am very interested in this topic if anybody has feedback. And just to leave you with, I've got a AI generated image of APIsec Labs logo that I described. Had no visible text on it. So thank you.